Hello, everyone. My topic is improving software quality planning using machine learning techniques. Our agenda today is we're gonna talk about motivation. Actually, I will talk about motivation, the context of the problem, methodology that I will suggest to, let's say, solve the problem, and conclusion. Okay, before moving on the main topic, let's talk about software quality. So this is the, let's say, formal definition of software quality. That is, this is kind of degree to which a system, component, or let's say software product meets the specified or expected requirements of a user or client, right? So this is a formal definition of software quality. Okay, so let's switch to some easy definition. Okay, let's talk about some easy definition. So this is basically software quality is basically desirable attributes of software products, such as, let's say, reliability, flexibility, efficiency, usability, testability, portability, and we can also list such as security, maintainability, etc. Right? So these are the attributes that client or users would like to get from software product. Okay, so you might have a question like, okay, Sroj, these are amazing, these are great attributes. How can we achieve such attributes? So I have an answer to your question. So there is a amazing, let's say, process or let's say category of processes called quality management. So this is kind of the definition of quality management is just let's say comprehensive process or let's say joint process that ensures software is compliant with its requirements, or in easy way we can say that software product meets its requirements. So quality management is the way to achieve this let's say desirable attributes, right? So quality management itself also let's say contains several phases or several steps, such as quality control, quality assurance, and quality planning, right? So you can guess by the names of these phases what are these let's say phases. We will we're not gonna, let's say, spend a lot of time on the unnecessary phases, and now let's focus on this quality planning. So quality planning is just a document, or let's say several documents that specify quality standards, resources, specifications related to, let's say, software product or software service or project. So we can say that quality planning is kind of map of quality management. Okay, how can we, let's say, proceed with our quality management? So we can define everything in quality planning. So you can guess that quality planning is very, very, very important phase of quality management, right? So everything starts with, we can say that everything is defined in quality planning. Okay, so this is a quality planning that we are focusing on, that we are trying to improve this process. And whenever we think of any process, nowadays we think about automation and let's say balance between manual versus automation. Let's say uh, always in our mind, right? This, let's say, balance or imbalance is always in our mind. How can we automate some process? As Albert Einstein once said, "It's become appallingly obvious that our technology has exceeded our humanity," right? So we can think about automation of any process because it's gonna be cheaper. We're gonna have great results, and let's say the process itself will be improved overall, right? Okay, when we think about automation of process nowadays, machine learning is the next step. So we can think of machine learning is not future but present, because machine learning is already applied in, let's say, several fields of our current, let's say, our world. Okay, so uh, I would like to also justify machine learning, let's say, approach and several words, such as because machine learning is progressing and improving dramatically, right? Because it's already showed great result, and also the quality planning that we are going to improve has well defined several steps that we can apply machine learning easily on this quality planning. And of course, after applying machine learning, we're gonna reduce manual work, which implies improvement in the planning, right? So this is why machine learning is, let's say, can be one of the best ways to improve quality planning. Okay, so here in our current, let's say, topic, I would like to suggest application of machine learning in in quality planning in three steps, right? Okay, so the first step or the first phase should be should be defining quality attributes associated with the domain field of the product. Okay, we have, let's say, we have talked about quality attributes, right? You remember. So these are maintainability, security, efficiency, and so on, so on. So first of all, we have to define these quality attributes. Okay, after we have done with this step, we have to move on to the second phase, which is metric structure. Okay, after we have defined quality attributes, we have to define some metrics that we can measure uh, quality attributes. Okay, so in order to evaluate our quality. And after this, of course, in quality planning, we have to also estimate risks related to, let's say, product deployment or product development. So overall, to, let's say, our software, product, service, or project. Okay, so these three phases, after applying these three phases, we can consider that automation of the whole quality planning is partly implemented. Of course, there are other parts, but still, after applying these three, let's say, phases, we can think that we have automated most of the quality plan job. Okay, so uh, let's talk about identifying quality attributes. So here, I would like to suggest, let's say, application of neural networks. I mean, because they have showed great results, right? So, and training, let's say, classification, neural network classification algorithm on the existing projects that are already associated with some, let's say, quality attributes, right? We have a lot of open source projects, and uh, and most of them we can associate with quality attributes. So we can train our model on the existing, let's say, projects. After that, our model is ready, and whenever we, let's say, input our some, let's say, domain or the requirements into this model, we can extract quality attributes, right? So of course we're going to apply several, let's say, machine learning algorithms and pick up the best one. Okay, so the next step is, of course, metrics. I mean, we have to pick up the metrics with to measure our quality attributes, right? So here we have amazing, let's say, standards called ISO. So ISO described software metrics uh, in a very detailed way, right? So we can employ these descriptions uh, for our usage. How? We can also take this information and train our machine learning model onto them in order to have some model that can extract measures on some quality attributes, right? So we can also apply GKM approach onto the machine learning algorithm. So this is basically goal question metrics, right? In our not only machine learning algorithm, but in the overall phase of metric structure, right? In order to identify the correct metrics to measure our quality attributes. Okay, great. So I hope that we're doing great. So let's move on to the next or the final stage, which is risk prediction. So, of course, whenever we think of product deployment or product development, we have to think about risks that may appear during the development or during the deployment, right? So, uh, we suggest to, let's say, use anomaly detection techniques in order to identify the risks. How? We have already let's say, successfully deployed or successfully developed projects, right? I mean, existing projects. By using their data, we can, let's say, we can extract the successful ways of development and of, let's say, deployment. So after using this data on anomaly detection, we can predict some, let's say, uh, abnormal situations which can predict risk during the uh, let's say project development or project deployment, right? So this is how we are suggesting, let's say, using this is how we are suggesting to predict risk using anomaly detection. Okay, great. So back to the history, not back to the future. I mean the quality management slide. So this was our slide, right? Where we focused on quality planning. So after applying these steps, which are identifying quality attributes, metric structure, and risk prediction, we can consider that quality planning is automated, and we can think that after applying the previous three phases or the previous three steps, this is done. The quality planning is done, completed. So uh, as a conclusion, we can we talked about quality management, quality attributes, and quality planning overall. So here we talked about quality planning can be automated, right? We justified this automation by several factors, and this automation, of course, uh, is going to bring a lot of improvements on quality planning overall. So, as a way of automation, we have considered machine learning techniques, right? So, we have, let's say, defined this automation into three phases, into three steps, and in each of the steps, we suggested to use machine learning techniques. right? So this machine learning is one of the most comprehensive or one of the best ways to improve quality planning. So again, so we have uh, applied, we have suggested application of ML in a systematic way on the following phases, such as identify quality attributes, metric structure, risk prediction, right? So in each of these phases, we have suggested how we can apply machine learning. So this was our let's say topic about improvement of quality planning using machine learning techniques. Okay, thanks for your attention and thank you a lot.